So what is the exam about? The Praxis is about? This is a subtest of the elementary education, the multiple subjects test. A part of the social studies and the science and the math is, of course, the math subtest. This link that we have provided here for you, which is the ETS website, is actually provide you with some resources on the exam itself and how you schedule your test, where you test and plan your test, some scores, and also it includes some study plan, which is something we will tap into today and talk about it. You have also Khan Academy, you have some programs as well you could tap into, and you have some interactive practice tests. These are practice tests. Some of it is for free, some of it is for purchase. So just to keep you aware of what is available there for you. And this is also for the other subtests. So if you are also preparing for social studies, science, you could also use these information. So if we talk about mathematics, what are the topics that we should cover in mathematics? The topics are numbers and operations, algebraic thinking, which what you have alluded to, Graciela, geometry and measurement, data, statistics, and probability. And these questions are spread on the whole 50 questions. 20 of them, or 40% of them, will be on numbers and operations. So the big bulk of it is on numbers and operation. 15 questions, or 30%, will be on algebraic thinking. And the other 30% will be on geometry, measurement, data, statistics, and probability. So what we will do in this session, we will go for each of these categories and provide you with some representative questions that could help you prepare and think with these categories. And if you have any questions, please don't hesitate to ask. I want you to be present during this presentation because this is meant for you. And since you are here, you care about doing well on the Praxis, and we're here to support you and answer any of the questions or inquiries you might have. So one of the things that would like you to take a look at, which is the study plan for the Praxis 5003. And what I'll do, I'm going to send this in the chat because I want you to have access to it as you come. Please let me know if you have access to what I just sent you. And you could feel free to open it and walk through the document as I explain how to use the study plan to focus your attention on the topics you need as you prepare for the Praxis. If you recall the categories that we just mentioned right now, numbers and operation, algebraic thinking, and geometry and data, these are itemized, or we have a study plan for each one of them and the topics listed under each of these categories. So, for example, if I am to be tested on numbers and operations, these are the major topics that the Praxis will assist you on. So I have to understand the place value. So if you don't remember it, like Graciela just mentioned right now, she really cannot remember the linear equations and the algebraic thinking, then you probably want to go back and research the topic, go probably to a grade 5, grade 4, a math book, and try to understand how the place value system works. And once you are good at it, just rate yourself, check the mark there, and move on to the next topic. The study plan, actually, I mean, we all know that math is really vast, and where to prepare, how to prepare, and what topics to include. This is your blueprint. Go visit this often. Start with the numbers that you know or with the topics you know, check them out, and then focus on the topics that you don't know. So if I am Graciela, probably, and I'm sorry, I'm picking on you, I don't mean to.
No, you're okay.
If you want to go down and look at the algebraic thinking, identify each of these items and assess yourself. Do you know how to differentiate between the expressions and equations? If not, towards the end of this session, we will provide you with some resources that you could also focus your attention to this study plan. So keep this handy, keep it as your blueprint that will guide you through the process of preparing for the Praxis math, okay? this is where you begin identifying and evaluating yourself and see what kind of things that you have to focus on. And in terms of the Praxis itself, it's an interactive computer format, meaning it's a selected response. So you're going to do it as on a computer of a kind. You could make a choice, you could write a text, you could write a sentence, or you have to respond to part of graphic. So the questions are computer delivered tests. So you have to be also familiar with how to operate that device in order to write your responses in text or select your responses. On some cases or on some questions, and a calculator will pop up, so you are allowed to use the calculator. It's not for all tests, but it would be allowed. And I apologize, Dr. Powell, looks like I went over your slide.
Oh, that's perfectly okay.
Oh,
I'm okay with that. Let's see. On understanding selected response questions, read the questions and answers thoroughly. Verify your answer through substitution if you can. If it's an equation, you put your answer back into it. Limit your answers to the choices given, of course, and eliminate incorrect answers. And that's kind of tied to read the questions and answers thoroughly, because sometimes when you look at it, it's like, I call it the odd woman out is that 3 out of the 4 things have something in common. So it's kind of like the answer has to be the 4th one, but we'll talk about that more. Dr. Salem, can you advance?
Yes.
Or can I advance? I didn't know who could advance, okay? That's me. Number and operations. This is I don't know how to put it, a content area in math. And the operations are addition, subtraction, multiplication, and division. And you have to interact with and how they relate to each other. That's what this topic is. And our number system is a base 10 or a decimal. Next, please. Now, I would like for all of you to have a piece of paper out and see how you're doing. Try to do this one. Let's read it. Which of the following numbers is the product of 1 even number and 2 odd numbers, assuming the factors are greater than 1? Greater than 1. So that's, yeah, that was, when I looked at this, I was like, Now, does anyone have any thoughts about this? What do you know about even numbers?
Like 2, 4, 6, 8, 10.
So that's, yeah, and they have those in the play. And odd numbers, what happens when you multiply an odd times an odd? Pick one. And what kind of number do you get? Pick 2 odd. Okay. So, and what happens when you multiply an odd by an even?
You get an even number.
Now, Dr. Salem and I actually discussed this problem yesterday when we were preparing, and she took a number theory aspect, and I just more like a bull in a china shop. Okay. Does anyone have any thoughts on this? How would you begin this, giving the stem or the question? Do you know any of the vocabulary that was used? What vocabulary are you familiar with in the stem of the question? We have a product, we have an even number, and 2 odd numbers. Now, what does product mean? We have
multiply.
factors too, huh?
To multiply.
Yeah. So what we're going to do is we have to look at these numbers, and when we factor them, see which ones give us 2 odd and an even. And that's exactly what I did. And I started with 12, and I did the factors of 12. And the factors of 12 are 1, they said not to use 1, 2, 3, 4, and 12. 2, 3, 4, and 12. Now, what kind of numbers are 2, 3, 4, and 12? Even or odd?
Both.
Huh? Well, let's hold on. But it told us we had to have 1 even and 2 odd, correct?
Yes.
Okay, so what is that? So does 12 work? Wait a minute, share. I'm gonna go to my share screen, but it's gonna take the problem off, okay? Because we want to look at it. Continue.
I have listed the numbers that the question is asking us to. Following numbers are the product of 1 even number and 2 odds number. Which one of these is the product of 1 even and 2 odd? Okay, I'll follow your lead, Dr. Powell. You talked about the factors 2 and 3 and another 2 and 12, right?
You either want to do the prime or just all of the factors and not mix them up, like 2, 3, 4, and 12,
2,
which are not the prime numbers,
4,
right?
12.
Yeah. Or you can do the prime factorization, either one. Okay.
For 18.
2, 9, 3, and 6,
And for
and
6.
18, right?
Mhm.
20. I think you better do the prime ones, don't you?
Yeah.
Okay, do the prime. 20 is 2 times 2 times 5. Okay, and 28 is 2 times 2 times 7.
And this one.
And I'm helping too much. So that one is 2 times 3 times 3. And 12 is 2 times 2
That's 4.
times 3. No,
Oh,
yeah, yeah, 2 times 2 times 3. Yes, that's correct.
these are the factors.
The prime factors. Yes, ma'am.
Right.
Prime number factors.
Does this help you with finding the answer?
So basically, when we're trying to find the prime factor, we're just trying to find the most basic way to multiply numbers to get to that big number.
Yes. So you're asking about why we did 2 times 2 times 3 for 12?
Right.
Is that what you're asking? Okay. Yes. The prime numbers make up all numbers. So yes, prime numbers have exactly 2 factors. And the list is 2, 3, 5, 7, less than 10. And then it's 11, 13, 17, and 19. And those are all of them less than 20. And I can't imagine they're going to give you anything less than that. More that you'll need more than that. So it said the problem read the product of 1 even number
And 2.
and 2 odd numbers.
Which one of these represents one even factor and two odd factors? I'm checking the chat. 18. Madison said 18. Do you agree with Madison?
Yes.
Yes. Okay, next one.
Okay, that's me. I'm going to read it and I'm going to ask you for your thoughts on it, okay? What value does 8 represent in the number 2.86 times 10 to the 4th? Madison, do you have, what are you thinking when you read this problem?
My brain kind of goes to like money because it had the decimal. So I kind of try to think when there's decimals in like money.
Okay. What else is written in this number? That's a little unusual.
Exponents.
Yes, and we're going to have to transfer this exponent form into standard form so we can know what we're looking at. What is 10 to the 4th power? Okay, 10 to the 4th power is 10 times 10 times 10 times 10. The base is 10. The 4 is telling you how many times to multiply the 10. And 10 to the 4th power is equal to 10,000. Okay. So we have to multiply 2 and 0.86 times 10,000. Now this is called scientific notation. And what it is scientists deal with such huge numbers, they wanted to be able to abbreviate their number system. And that's how they use the exponents. So if we multiply 2.86 times 10,000, we would really have to move our decimal place. How many places? 4 places, okay? Okay, 1, 2, 3, 4. Yes. Now let's answer the question, because now that we got it in a form that we know about and can understand, what we're going to do is, what does the 8 represent? What place is the 8 in? Place value. You start with ones, then go to what? Tens, hundreds, thousands, right? So that 8 represents 8,000, which is answer C. Okay.
Any questions so far? All right, let's take a look at the next one. And remember, we talked about the scientific notation. The scientific notation goes both ways. It represents large numbers, but at the same time, it represents very small number, which is less than 1. So the sizes of 4 microscopic organisms are measured for comparison in a research project. One of the 4 recordings below, which is the shortest in length? Remember, when we were talking about numbers less than 1, it's slightly different when we talk about numbers larger than 1, okay? So I want you to take like 30 seconds to look at the numbers, think about the question, and think of the best strategy to solve this problem. Just 30 seconds, think about it. And feel free to write your thoughts in the chat or even your questions. So these are the numbers that we have. Can anyone suggest, similar to what we have done in the question before, we multiplied by 10, 10, 10, 10, which is 10,000. What do we need to do here in order to get the number without the exponent? What do we mean by 10 to the power negative 5?
Decimals.
Now, that's right. We're going to convert it to standard form. Okay. But what are these numbers going to look like? Are they going to be really big or really small?
Small.
Really small, right? And of our choices, because they all have one number in front of the decimal. So what are the two smallest numbers here? Out of this list, which is?
Madison said 0.00001, which is 1 in the 100,000.
Okay, and let's tenths, hundreds, thousands, tens of thousands, hundreds of thousands. Yes, remember the first place after the decimal is the tenths place.
Right. The trick to this question without converting any one of them is looking at the exponent. Once the exponent is big in terms of the absolute value, the number is smaller, right? So 10 to the negative 5 should be smaller than 10 to the negative 3. And 10 to the negative 5 should be larger than 10 to the negative 6, right? Because we're going smaller. So the smallest of the exponents are 10 to the negative 6. Do we agree on this?
Yes.
So that eliminates this one and this one. So we are left with two numbers to look at. And that's easy to compare because they have the same exponents, but one of them is 2.7 and the other one is 1.8. So which one you would pick, the 2.7 or the 1.8?
1.8.
The 1.8. So this is your correct answer, even without switching to the standard form, because remember, we want you to be as quick as possible because you actually have like a minute and a half for each question if you want to just do the math and see how much time is allocated to this test. So the answer will be C, which is 1.8 times 10 to the negative 6.
And does anybody recall earlier when we said, look, read the question and the answer? And that is why, because you could have worked this problem just by looking at the answers.
Yeah. And a lot of questions are like this, where you just can solve it by elimination. Okay, let's try the second one. Which of the following has the greatest value? We're still in place value, and now you can see how the operations and the number sense is actually working in the exams, the Praxis exam. So take 30 seconds to take a look at this. Try to use your scratch paper to come up with an answer. All right, any thoughts? We want the greatest value. So we want the largest number of these three. What do you think? Talk to me. What is 3/10?
It's going to be closest to the decimal.
Very good, which is 0.3. Do we agree? So if just a reminder, this is the tenths, this is the hundreds, and this is the thousands, and so on and so forth, okay? This is how the decimal place value looks like. So when we say 3/10, the 3 will go on this place value. Okay, what about 2700s? How do we write it? $2,700s. This is the hundreds. So 2,700s. 36,000s. So we are in the thousands here, and we want to write 36. So we will have to leave a 0 and then write 36. The 600s, 1, and this is the hundreds. So the 6 will go here. So it's 0.06. Can we now determine which one is the greatest?
A,
Which is
0.3.
3/10. Very good. So that is 3/10 that we will have to pick from here, which is the answer. Questions? Right, Dr. Powell?
Okay, after building solar-powered cars in Mr. Bosu's engineering class, students raced the cars to find out which one was the fastest. Which of the following speeds in meters per second is the greatest? 9/10, 17/20, 4/5, 38/40 over 40. So what are your thoughts? Anybody have any thoughts? We need to get them all looking like the same, right? Do we agree? We have decimals and fractions, and I would want to turn them all into one or the other, correct? Make the fraction a decimal. Why do you say that, Talitha?
Yeah, I guess to get them all look the same.
Mm-hmm.
It's easier to compare decimals than it is fractions, in my opinion.
Okay, but that's a lot of more work here, isn't it? Because we only have one decimal, right? Am I wrong?
Yeah.
It's only one decimal.
Mhm.
So that's a choice that you would make based on your knowledge. And I can tell you, for me, I would take them all to fractions. And that 9/10, I would make, it's just exactly what it says. It's 9/10, 17/20, okay, 38/40. Now, what would be the common denominator with those? 40, 5, 20, and 10.
10.
Common denominator?
I don't know.
What would be the common, what number will all those denominators go into? How can we get the bottom number the same for all of them so we can use the top number to do the comparison?
If you do 40, then you could do
Yeah, let's try 4. That is correct.
5 times 8 gives you 40. So then you would just, what she's writing.
Times 4, okay. So that's 36/40 for 9/10. 34/40 for 17/20. 32/40 for 4/5, and 38/40. Now, what's the largest one? That is
D, 38 over 40.
yes.
I'm going to take just a minute to talk to walk through Talitha's suggestion to the decimal. If we
Yes.
want to do that, it's a correct strategy. It's just going to take a little bit longer. And remember, time and knowledge are two factors that we have to focus on when you take the Praxis. If you want to do the decimal, you're going to have to do 17 divided by 20, and you're going to end up doing long division if you don't have a calculator, and most likely this one without a calculator. And you would also do the same with 38 and 40, and those are relatively large numbers to deal with, and also you will have to do long division. So the time you spend here and there would actually maximize the time you're going to spend on solving this problem, where you just really quickly, even without multiplying, you could do this by mental math and come up with the 36, 34, and 32, and 38, because the numbers are very much close to each other. Does that make sense?
Yes.
Okay. All right, next.
Oh, this is me. Oh, this is mine. Oh, I'm teaching this right now. Okay, what are the greatest common factor of 160 and 48? Who remembers how we do greatest common factor? There's two ways we can list all of the factors of two numbers, or we can use the prime factorization. There we go with that prime factorization again, and use that to find the greatest common factor. And the most efficient way is using, when you have large numbers, which that 160, it's going to take you a minute to get all of the factors of that. So I would recommend the prime factorization in this. So what's the smallest prime that goes into 160?
1.
1 is not prime. What's the smallest prime that goes into 160? You're close. You're very close. It's 2. Okay. 2 is the first prime. 1 we took off the prime number list. But so 2 is the first prime number, and it is the only even prime number. So 2 times 2 is 4, times 2 times 5. Then let me go back and touch that. 8 times, I'm gonna need another 2 in there, times 2, and then one more, I think. 2 times 2 is 4, 4 times 4 is 16, and 16 times 5 is 80. So I need one more 2, okay? Now, what about 48? The prime factorization of that is, can somebody help me? Lily, can you help me with the prime factorization of 148?
48.
I'm sorry, 48. Thank you, Dr. Salem. I'm gonna have you find the primes. 2 times 2.
4.
4 times what equals 48? Anybody know? Dr. Salem, can I get you to tree that 48 for
12.
me? Okay. Okay. Yeah. 12. But 12 is 12 a prime number?
I was saying the 4 times 12, because you said what times 4?
Yeah, yeah, that's correct. Okay. Yes. That's what I was saying. And you remember the tree diagram, correct?
Mhm.
That's, I think, what they're more used to is to do the tree diagram to get the prime factorization. Now that's the division algorithm. So what factors do these two prime factors do these two numbers have in common? Anybody?
2.
That's what they have. 1, 2. Do they have another 2 in common?
Yes.
Okay. So we have to write both of them down because they're in both numbers. Okay. Any prime factor that is in both numbers gets counted for the greatest common factor in both of them. Is there any other prime factors in both numbers besides 2 to the 4th power? Nope, the one number has a 3 left and the other one doesn't have a 3, so that doesn't count. And the same over here, that one has a 2 and a 5, but it's not in the other one. So you just multiply 2 times 2 times 2 times 2, which is 4 times 4, which is 16. And that is the greatest common factor of those two numbers. Anybody have any questions? Don't understand what we did, why we did it? Y'all are a silent bunch.
The tree method that Dr. Powell suggested is really powerful and helpful. Start with the 2s first, and then if it doesn't work, try the 3, and then if it doesn't work, try the 5. Start with the prime numbers and you could get your factors easily.
And the big thing for you is to remember what are the prime numbers, you know, to start off with, right? 2, 3, space 3. This is you, Dr.
Yes.
Salem.
All right. Another example of also understanding the content of number sense or the numbers and operations. This is another question that asking us to order the numbers from greatest to least. We have -2, 1/2, 76 hundredths, 5, square root of 2, and pi. Does anyone know what's the value of pi?
3.14.
The value of pi?
Hi. Why?
3.14. And so on.
Actually, 3.14. Yes. Yeah, it's 3.14. So you have to keep that in mind when you order these numbers, 3.14.
Oh, that's pi. I thought that was in. I'm like,
Yeah.
why is Dr. Salem talking about pi? I'm like looking down trying to figure out what question. Okay,
I thought so, but the end did not make any sense to me. So when I looked at it,
that looks a lot like it, and that's pi, approximately 3 and 1400ths.
Yes.
Right.
So take a minute before I show you how to think of this problem till I copy it to my pad and try to formulate your strategy solving this.
Looking at the answers. From greatest to least.
Yes.
Oh. Well, how about we go, which one of those numbers is the largest? Can we even ask ourselves that without doing any work? Can we ask ourselves which one of those numbers is the largest?
5. So you could eliminate C and D because it had -2.
At first, right?
Yes.
That's one thing. But of these numbers, looking at them, which one is the one that is farthest away from 0 to this side, in the positive direction?
5 is your greatest number.
Yeah. So 5, since 5 is your greatest number, let's go and look at our options again.
And eliminate C and D because A and B were the only ones that had 5 as the greatest. The other ones were trying to go least to greatest.
Very good.
And even when I look more, I even see more, but maybe I'm too sophisticated.
And I would put the pi here because 3.714.
Approximately, yep.
Okay. And the square root of 2 and this.
Has to be before 1.
I'm sorry, Maddie.
Oh, that's a positive. I mean, negative 1/2. I didn't see your negative sign, but your negative, that's before a 1.
Hmm. I don't see a negative before 1.
I was saying, I didn't know that I didn't see the number line. It was
Oh,
like,
this is
I was
not,
that the negative 1/2 has to be before the negative 1.
yes.
But I didn't
1/2 is not negative in this list, though.
This is 1/2.
It's positive 1/2 if
Yes.
we look at the question.
Yeah, that's my error. Okay, thank you. Okay, I don't know where my camera went. Okay, so far we agree on this. So that leaves us with 7600s, which is going to be and the square root of 2. Where do you think we need to put them? They should be somewhere here. Which one is the smallest, smaller than the other one?
The square root of 2 is 1.4, I think. So that would be before 0.76.
Right, so this should be here. And this should be the square root from here. So the order would be -2 from the least to greatest, or from greatest to least. 5 pi square root of 2, 76, 1/2, and -2.
Would the square root of 2 not be 1.4? Wouldn't that come before the 0.7?
One more time, the square root of
2, isn't that
Yes.
1.4?
1.7, I think,
I think it's 1.4.
or 1.4. But
I think
regardless,
it's 1.4.
it's still going to be between the pi and the 0.76, right?
.4 would be bigger than 0.7.
Yes.
Yes, and we're
Yes,
doing greatest
0.67.
to least. We're numbering them from greatest to least. So the square root of 2 goes before,
0.76.
because we have something in front of the decimal that's not negative, right? I didn't catch who was asking about the square root of 2 and the 76/100ths, but do you understand that the square root of 2 is larger? Right? You guys, when I looked at that number list, I knew exactly what the answer was without doing any work, believe it or not. But that might be very sophisticated. You had already decided it was between A and B, correct?
Correct.
Now, I looked at the last number on A and the last number, or the last two numbers on A and B are interchanged, right?
Right.
So one of them has a negative in front of a positive number. So that can't be right. 8 cannot be right.
Right.
1/2 is larger than -2 because it's a positive number. So I knew the answer was B without working anything out.
Right. And that's the great.
And the same thing with the C and D, they had -2. There's no way there's no negative number that is larger than 0 even, or it's definitely not larger than a positive number, right? Okay. We watching our time? I bet you we're taking up much more time. Okay, let's see.
I'm gonna skip those and
Yeah, I
do
just,
this, for instance.
oh yes, because that was all number and operation,
Right.
right? So you're going to a different topic.
Mhm.
And what topic is this, Dr. Salem?
Still number and operations.
Okay.
Let's move to, I would like to just stop by this problem.
Okay.
Illustrate the identity property of addition. You should also go over the properties of addition and multiplication and division. Those are always, there is a question or two on the Praxis to discuss the property of addition and subtraction and multiplication and division. The identity property for addition is when you add a 0 to the number. So 3 plus 0 or 0 plus 3, we call this the identity property. Sometimes we know these properties, but most of the time we just don't associate the name with the property. So all I'm asking is to go back and refresh your memory with what are the properties of addition and subtraction or multiplication and division. Let's do some geometry and a little bit of probability as well. Here is a question. Identify which of the following triangles are acute, obtuse, right, or equiangular. Okay. And we have A, B, and C.
And of course, we would want to know what those words mean.
Mhm.
We cannot answer this question without knowing what does obtuse mean in math, and an obtuse triangle. What does that mean? What's the definition of obtuse?
Obtuse is over 90 degrees, right?
That is correct. And an obtuse triangle is, just like you said, a triangle that has an angle greater than 90 degrees. Now, what is an acute triangular?
Less than 45.
Okay, in a triangle, there's 3 angles. And when you have an acute triangle, all 3 of the angles are less than 90 degrees. Okay.
And the right is 90 degrees.
Right? A triangle with 90 degrees. Okay.
So based
Now,
on
what does equiangular mean?
All 3 are the same.
All 3 what are the same?
All 3 angles.
That is correct. That's what it means. Okay.
Okay.
Just like it sounds, equal angles. Okay. Now, choose the correct classification below for identify each of the following triangles as acute, obtuse, regular, right, or equiangular. There may, aren't these fun when you have two answers? Choose the correct classification. So, triangle A, tell me what we know about it by the drawings on it.
It has acute angles.
Okay. 3 acute angles, right?
And they're all
and there are equals, and all of them are equal, correct ratio, which is more than 90 degrees. Another question on geometry. A student wants to know if a triangle can have 2 right angles. What would be the response? No, a triangle cannot have 2 right angles because the sum of the interior angles of the triangle would be greater than 80, 180. Yes, because the third angle could be 0. No, cannot have 2 right angles because the measurement should be less than 90 of the interior angles. And yes, the triangle can have 2 right angles. There is no restrictions on the measurement of any particular interior angles of a triangle. What are your thoughts?
My thoughts are that a triangle cannot be greater than 180 degrees in angles.
That's correct. And that is a piece of information in reference to the triangles. All the angles should be totaled to 180 degrees. So if one of the angles is 90, the sum of the 2 angles will be 90, but there is no way that we would have 2 angles with a 90-degree measurement.
There's no room for a third angle.
Right, Dr. Powell?
Okay. That was me. I'm sorry. Independent. A student would like to know the difference between 2 events being independent and 2 events being mutually exclusive. Woo, how would you answer her?
What do we mean by independent events?
2 different events?
I didn't hear that.
Okay, you say 2 different. What do we mean by mutually exclusive?
They can't exist without the other.
Mm-hmm.
Mutually exclusive means you either have one or the other one, right? They exclude each other.
Okay.
Isn't that correct?
Mm-hmm.
Yes, they exclude each other. You can't, mutually exclusive a blind man seeing is a mutual exclusive. You
Okay.
can't be, if you see what I'm saying? Or, okay, that's what, somebody told me that 100 years ago. I've obviously remembered it ever since. Okay, two events are independent when they have at least one outcome in common. Two events are mutually exclusive when the occurrence or non-occurrence of one event has an influence on the outcome of the other event. Two events are independent when they have no outcomes in common. Two events are mutually exclusive when the occurrence or non-occurrence of one event has no influence on the outcome of the other event. Two events are independent when the occurrence or non-occurrence of one event has an influence on the outcome of the other event. Two events are mutually exclusive when they have at least one outcome in common. D, two events are independent when the occurrence or non-occurrence of one event has no influence on the outcome of the other event. Two events are mutually exclusive when they have no outcomes in common.
Which is why this question is really just a reminder to some of the definitions in mathematics that you have also to be aware of it. So when you review for math Praxis, just make sure you go back and go over the terminologies and the vocabulary so you are aware of what to expect in terms of language.
No outcomes. The answer to that one was D, by the way.
Oh, yeah.
Okay, independent events don't influence each other.
Yeah.
That's what it said is independent. Okay. If you roll two dice, does what's on this dice affect what's on this one? No. Rolling two separate dice are independent events. What's on this one does not affect this one. Okay. Oh, there's the star again. If the number of professors in college is X and the number of students is Y, and there are 10 times as many students as professors, 10 times as many students as professors, the algebraic equation that shows the relationship between students and professors. Now, I just taught this yesterday, and I had to teach myself this when I was in algebra. What's the smallest group between these two? The professors or the students?
Professors is smaller than students.
Okay. So if you're going to multiply something, what are you going to have to multiply?
The amount of students times the professors. I mean,
Which
10
number
times,
would you multiply? The professors or the students?
you're multiplying it times the professors to get the students.
Right. So the 10 or whatever the multiplicative thing has to be with the smaller group. So you told me the smaller groups is professors. That is correct. And that is represented by X. And that's the number we have to multiply by 10. Do you understand that?
Yes.
Okay, always start with what's your smallest one and add to that or multiply it, okay? Okay, next.
All right. Now, we're also on the algebraic equations. How can we add the following two linear expressions? 5x minus 9, and we're going to add to it negative x plus 7. How could we do this?
Well, first you could do, if you're adding 5 and a negative number, you know that it's going to go down to a positive 3x.
Uh-huh. Very
Because
good.
your positive number is greater than your negative number, so you know that it'll still be positive.
Very good. So you went ahead and looked at the number,
The x value first,
variables. This and this, right?
right?
So you add the numbers with the variables, which is 5x plus negative 2x, which is equivalent to 5x minus 2x. And as she said, this will bring us to 3x. Very good. Next step. So we added those. Now what's left for us?
If you have a -9 and you're then adding 7, 9 is bigger, so you know that you're going to have a negative number left over because your positive number is not bigger than your negative number. So that lets you know that you're going to have a negative answer.
Very good. So -9 plus 7 will give us the difference between the two of them. It's 2, and it will be negative because we have larger absolute value of this number. So we will have more negative here. So now put this together. So what is the answer?
3x.
3x.
3x
3x
You
minus
wrote down
2.
2x minus 2.
minus 2. Oh,
Go to your answer, Dr. Salem. Yes. Okay.
yes.
The coefficient in front of, okay, Madison, that was excellent, but you knew about like terms. You knew not to add 5x and 9 because they're not like terms, right?
Yes, ma'am.
You didn't even know you knew that, did you? So you didn't even talk or think about that. But some people might need to know that like terms are the same variable to the same power. So because the variable is x and the power on that x is what? What's the power on that x?
1.
1 because it's not stated.
Mhm.
Yes, exactly.
Very good.
I wasn't asking you, Dr. Salem, but okay. Next, that's all. 3x minus 2.
Can't help.
Okay.
Oh, this is also a concept that relates to equivalent fraction. And I taught this yesterday, similar to Dr. Powell. We were talking about equivalent fractions. And one way of identifying equivalent fractions is actually simplifying both of them and finding that they're equal. Another way of doing it is the cross product. So if 5/6 of a class was absent due to illness and 8/9 of the school was absent due to illness, is the fraction of the class that was absent equivalent to the fraction of the entire school that was absent? We have no, because the cross products are equal. I mean, those are like, as we said, mutually exclusive. Yes, because the cross products are not equal. No, because the cross products are not equal. And yes, because the cross products are equal. What do you think? Do we know what a cross product is?
No.
I would say no because they're not equal. Those fractions are not equal to each other.
Yes.
How do you know that?
Because I know that, can I see the fractions again?
Yes. Wait a second.
I know that 8/9 is bigger than the 5/6, right?
How did you know that?
8/9 was bigger
How did you know that?
because I just did division in my head really quick and I knew. Because I'm better with decimals, so I just did the division.
Okay.
I had a scrap piece of paper and like wrote it down real quick and I knew the 8. I didn't even have to finish working it out. I knew that that one was going to be bigger. So I knew they were equal. So I knew that it had to be the one that said no because they're not equal.
I think there are 2 that say no, right?
One says no because they are equal, and then one says no because they're not equal. So it'd be no, they're not equal.
They're not
Okay,
equal.
that's
Very
good.
Yeah.
And you guys that are sprayed of fractions, I looked at that. I ain't gonna care about no cross product. I looked at how far is 5/6 away from 1?
1.
1/6.
It's 1/6 away. Write that down. How far is 8/9 away from 1?
1/9.
It's 1/9, right? So which one of those fractions is larger?
1/6.
One of the 5/6 is?
The one-
Oh, 1/6 is larger. So which one of the original fractions is larger than the other one?
5, 6.
Why do you say that?
I'm actually wrong because the way I did it, it's not 5, 6.
Yeah,
I just
but I want you
make
to
them common
okay.
denominator.
Okay, you're right. It's the 8/9 is larger.
Yeah,
Okay, because it's only 1/9 away from 1.
right.
And the other one is a bigger distance away from 1 because 1/6 is larger. I forgot to stop by 6/6 is 1 and 9/9 is 1.
8/9 is actually closer to 1.
Yes.
So that's why it's larger. All right, excellent work, everyone. Hopefully that was helpful. Dr. Powell?
Okay. Test taking tip reminders. Skip the hard questions. Is the test set up so that you can do that, Dr. Salem? Okay. Check your answers, read questions and possible answers thoroughly. Use all your energy to answer questions, not express frustration. Keep track of time. Okay. And I like to add, Dr. Ms. Perkins taught me something. When you take a sample test, do it timed so you can get a feel for how much time is passing. Okay. And what we all know about how we learn is first you do it by yourself, and then you get with a buddy that has already done it by themselves, and y'all get together and study together. Okay, that's what we know about success in education.
And remember, when you are taking the test, not everything is about math. Some of it is about test taking skills. Part of it is what Dr. Powell mentioned, time yourself so you know exactly the pace of the exam. So when you walk in, you know exactly the structure of it and how you could navigate these questions, and use these tips of the process of elimination, leave the hard questions. If you're stuck on one question, leave it and go back to it, and so on and so forth. We have listed some examples, some resources that could be helpful. The University of Memphis Library has excellent resource that you could also use. Let me walk you through it. And I'm going to send the link in the chat so you could have it for later access. You could add it to your bookmark it or add it to your list. They have really good books that you could rent, or you could use, you borrow from the library, or just you can go over it when you are at the library. The Praxis test, the core skills, and PTL, and searching for other books as well, and ebooks, you could go and find this. You have some videos and more. And I like this resource just simply because it's going to show you worked examples. So rational number operations, if you click on it, it's going to show you an example, pretty much like what we did here in this session. It's going to walk you through the solution of it, some of the tidbits and tricks that you could do to solve the problems. So all these are topics for the math Praxis that could be helpful. Feel free to go and review these examples, put a scratch paper and a pen next to you and work it out as they explain it. This is from Khan Academy. So this is really a good resource that I felt if I am a student prepping for the Praxis, those will be so helpful for me, the Praxis books, as well as the worked examples that could walk me through some of the content that I still need help with. And of course, you could always ask your professors for support, for feedback as well. The Math Methods courses provide you also with some of the content that you will find helpful in completing the Praxis successfully. And lastly, I just want to thank you for being here, taking some time from your busy schedule. I'm sure it's not easy towards the afternoon, late afternoon, to come and to a session like this, but I know you are invested in yourself and in completing the Praxis math. This is a Google form that I would like you just to take a minute to give us some feedback and comments that we could also use for our next session. We could assess your needs and see how this session helped in having you think of how you prepared for Praxis exam. Any questions?